Let's start from the top with Anand today.
Uh, Thank you. Yeah, it seems like an interesting idea to sort of complement the existing sort of, I guess, knowledge repository of LLMs or other neural networks with additional data. And it seems for that to happen, you sort of have to go through a numerical transformation process of converting structured or unstructured data into a sequence of vectors, which are then searched over for semantic meaning other than just, at least that's my sort of LI 5 understanding of it. I thought there was it was interesting, and I spent time in looking at. I spent a lot of time in reading through a lot of articles that Pinecone published, and that was really useful. And one thing that I found, I'll link it in the chat, was they did a comparison of a simple a comparison of embedding data sets for different standard evolutions, I guess, with MINST and other type of standard classic datasets that they compared with vectorizing using their own database, Pinecones, and using PostgreSQL database that's like an open source version. I thought that was interesting because it seemed one of the big bottlenecks with open source databases, vector search databases that is not purpose built for handling with embeddings with LLMs or other models is the sort of provisioning of huge computing instances and the sort of estimating the RAM usage per instance. It seems to be a bottleneck with open source, and again, the cost of it as a result of it, because they really need like big machines to process, store these embeddings in the RAM of those big machines to give sensible results. And so, ergo, they seem to have like a different, completely different business model for this, where apparently they charge you based on each query that the database is called upon. It is their serverless cloud offering. I thought that was interesting. And the other thing that was interesting was the sort of the cosine similarity that I found another article that talks about the sort of standard, often three types of similarities that these vectors tend to carry in like Euclidean distance between them. It's just like a general distance, and ecosine similarity, which is sort of a similarity of some angles between these vectors in that semantic space. And the other one that I thought was interesting was the dot product, where things are orthogonal to each other or they are directly aligned with each other. I thought that was different. I thought it was interesting that different mathematical tools are used in this sort of semantic space in some interesting ways. One thing that did occur to me yesterday while I was doing groceries, my wife was like, we were trying to think of if we have a certain grocery item at home and our recollection was very unspecific and sort of was specific to our idea of what that item is, and sort of it reminded me of like our raw input data that we had from home, so sort of sudden like an embedding, and we had sort of cosine similarity in our thinking, but then the accuracy of the thinking was quite different depending on what it is that we chose to embed. I thought that was interesting. But anyway, I'll stop there and I'll pass it down to Anuraj.
Yeah, so this seems initially I thought I have misunderstood something because the method seems to be similar to what is done in other fields like robotics. You do similar stuff that you convert it into a vector space, but I didn't understand how the actual like the meanings of text is given a numerical value. So that is something, yeah, I would like to understand. Yeah, and then yeah, I don't have much to say on this. Passing on to Gregory.
I read all three, marketing materials recommended, and I read the Substack post as well. And I tried to read a little bit further along those lines. And I was specifically interested in where exactly this semantic similarity comes from. or to be more specific, at which step, for example, the English word dog becomes similar to German word Hund. And it is not a trivial question as far as I can see after reading all those materials. So the model does not know that these two words are similar, that one is a translation of the another, that they signify the same object. It has to learn it somewhere, somehow, given an array of documents. So there should be some kind of a feedback loop hidden somewhere. Because if you just vectorize one word dog and then vectorize another word Hund, they're not going to be close automatically. So there should be some kind of a loop that brings them closer enough to be considered the translation of the same word. And so far, I can't pinpoint the step where this happens. So I will keep looking, I guess, and I will pass it on to Sachin.
Yeah. Interesting read. Yeah, I guess I was trying to understand how these how this data is reduced into sort of vector information, which I've not been able to understand. But yeah, I guess like Venkat commented, it seems like the new part is turning turning like things that were previously not vectorizable into vectors. And so I was trying to do some ChatGPT search into understanding that. It also made me think of I read a article about how Shein, the e-commerce company, makes clothes, and it's sort of like a real world reverse vector search sort of thing where it looks at like TikTok and Instagram and all that, and looks at what types of clothes or like fashion is trending, which I assume is some sort of like like information that can be reduced into like word clouds and vectors, and then uses that to manufacture clothes on demand. Yeah, so I was just thinking about how, like I guess when we use the yeah, I was thinking about sort of like how, like, what are like other cases in which real world data is virtualized and yeah, it's sort of used to sell something. But anyway, I don't have much useful to add. Venkat.
Yeah, it's kind of interesting. Looks like we're all struggling to actually understand how any of this works. So a couple of examples I found, also querying ChatGPT kind of helped a little bit. One was an example that says, how do you go from saying Paris is the capital of France to Rome is the capital of Italy? And it gave the example of vector math where it says the vector difference between Paris and France is similar to the vector distance between Rome and Italy. So you can do something like vector Paris minus vector France plus vector Italy. Does it make sense? So you're transferring the same distance and direction from the base of Paris to the base of Rome, or either way. So they're in a similar pattern relation. So that makes sense. So that would work even if there are like no documents actually containing all 4 words and saying things like, here's a list of countries and capitals. Even without a document like that, you can kind of like answer queries like, what is to Rome as France is to Paris. So that's one example. I was also trying to think of simpler algorithms that I've sort of like encountered before. There's one called term frequency, inter-document frequency, TF-IDF, you can look it up. That gets you to similarities between documents. So like if a term, say a particular specialized legal term occurs very frequently in legal documents, but not very commonly in other documents, TF-IDF would detect that similarity and determine that this broad class of documents is closer to each other. So I can imagine that you can include such context in vector embeddings. So I suspect what's going on is something like you take a piece of data and convert its sort of like raw content into a vector embedding in some way. So for example, like to take a very trivial, already numerical example, suppose you have like images that are like, colored geometric shapes like squares and circles and stuff like that, right? One of the simple things you could do is simply measure how much red, green, and blue is there in the picture. So you have an RGB value. So that already gives you an extremely basic vector embedding, which is if you have an RGB value, you can like look at all images and compute RGB distances and get things with similar proportions of red, green, and blue, right? Then you can like add other things, like you can apply a masking kernel, which is kind of like a square mask that you then move in rows and down a larger image, and maybe so that results in what's called a convolution. And then you can do the same thing, like the convolved version of the image, which, for example, if you do it a certain way, it'll average it. You do the same difference, and then you add it to the original vector. So now you're adding like more abstract levels of image information. And then, like, for example, there are kernels in convolution that detect things like edges. And that'll tell you, for example, if you're going from outside a square to inside a square. So you do that, and then maybe you detect that there are edges in the image, and that'll allow you to distinguish between things that have a particular RGB value because the colors are equally distributed across the pixels versus things that have an RGB value because there's like a red square inside a green square and the areas are equal, right? So it seems to me that the general process must work something like you take a piece of data, encode it into numerical form in some fairly arbitrary and obvious way, but then you start to infer context in a larger set that it belongs to and get more and more abstract sort of like class membership data and start adding that to the vector itself. And then you get like a really long vector out of a piece of data that includes more than just the information from the data itself. But this is kind of totally a wild guess. I think I'm still missing some basic intuitions on how this would work. And also I think I have some fundamental doubts on why would an arbitrary set of information be embeddable at all? Because there's like mathematical restrictions on that. Like it's not clear to me that just about any kind of data can be translated into sets of numbers that then form coherent spaces. Because in geometry, not everything is easily embeddable in spaces. I did also ask how is this used in LLM training, and it gave me some vague answers of like you take a training data set and you tokenize it, and then you store that token as a vector, and that part makes sense. I mean, that's how transformers work. So you take a sentence, and not only do you store the particular tokens like letters or fragments of words, but you also encode the position. So that gives you like a position encoded vector of the word or the tokens and sentences. Yeah, and you can do this at larger and larger scale structures. So if you have 1,000 token text, you'll encode the relative positions and frequencies across the whole text. So it's like looking at an image at multiple scales. So I can see vaguely how that would be converted in an embedding. But yeah, I think this is one of those things where you kind of have to play hands-on with some code before you'll get a sense of how this actually works. Kind of interesting that we've done this kind of exploration session before and tried to understand a topic, and sometimes it works well, sometimes it doesn't. This time it feels like there are no easy explainers. Yeah. Anyone have second round thoughts?
In the last article I shared, it's from a company called Elastic or something. Uh, they say the simplest encode the word embedding is just giving a count based on the number of counts it appears in the text. So that way I think like for example the art the word the in English, and if you translate the same to a German, it translates to d or similar, so the number of times that word would occur would be similar. So that way I think the count based ones you would get similar vector values in two languages. That is one of the simplest examples given. So and then probably there are like more complex ways of doing this.
I think one of the confusions or doubts I have is I can see how each of these mechanisms works in isolation. It's not clear to me how you would automate this, but because this sounds like a lot of humans like coming up with like a million clever tricks and then putting them in a huge training algorithm, and that's clearly not what's going on. Like trainings are much simpler. So there's some sort of way to automate embeddings using machine learning itself. So it's like you use machine learning to create the embedding and then you learn on that embedding or something. So it's like multi stages. The automation part is not clear to me.
Can I dribble in with something I'm curious about? Please, anybody just mute and jump in if I'm out of line here. But I've been enjoying Claude recently, partly because it's prettier, but also I've been reading good things about it. And I was curious if you folks who know some code, are you seeing this? I just Ed asked it, kind of the same stuff everyone else is doing. And this is what the code is. So like Anuraj, since you really can read code, is this at all, if I knew more, would this be useful? As in explaining, it's using stuff that this part, at least I can understand.
Are you sharing something?
Yeah, I fired up my screen. Let me zoom a little bit. Is it working?
Yeah.
Okay. So it chose Python and GenSim. And does it answer your question, Venkat, the MLM that trains the MLM question?
This
I
looks
knew
like a
more.
simpler thing called word to vec, not what LLMs used. So yeah, I think for sentences, this clarifies some things.
And then here's its own explainer about what it's doing.
So the point number 3 is interesting. So for each sentence, we calculate its embedding by averaging the embeddings of individual words. So this basically is like taking a sentence and running a query on each individual word. So you're like collecting the context of multiple words. That obviously creates a broader thing than just using the entire sentence as a single unbundled or bundled unit. So that's kind of helpful.
And it's the kind of weighting that if humans had to do it by hand, you forget it. You need to figure out how to make the computer do it.
Wikipedia has some mathematics on this word to vec, how it's done.
Do you want to take the screen over?
Just a second.
And again, it's kind of an experiment. We don't do this much.
You can have like multiple screens streamed at the same time.
Yeah, it's one of the great things about Discord.
Yeah. Actually, this is the same thing that is getting streamed right now. So we are watching and streaming the same thing.
And the stream automatically screen switches as well?
No, I have the OBS set up so that it
right.
shows
So
what
you'd have
we
to
are
tell it which
watching.
screen to show.
Yeah.
Continuous bag of words. Then we have to grab that for our glossary. Interesting.
Yeah, this guy had some rants for this word to vec a few months ago. I don't recall the incident, but I have seen this guy before.
Yeah, but both, I also posted the Wikipedia for TF-IDF. So I think Word2Vec, TF-IDF are kind of like simpler, less automated versions of what LLMs do. It seems to me that they really take an input and compute sort of like an analogical larger context set around it. And yeah, I think Anuraja's example is probably the simplest one, which is if you take a word like the and compute its frequency in a language and add that to the embedding vector, that's a very good way to make analogies across languages for very high frequency terms. TF-IDF does something similar within like what kinds of documents can you expect a certain term in even across languages. Yeah, so it looks like it's. So I'm trying to come up with the simplest dumb definition of embedding that I've learned today so far, and I would say it's something like, how do you not just convert a piece of data into a piece of data as much of its context made explicit as possible. Yeah, I think I'm going to have to do some more deeper serious reading and browsing before I get anywhere. Okay. No more thoughts. We can call it early. And I guess this is a good learning on where our limits of understanding are. So treat this as sort of an open, we need to understand it better topic. So if you find a better explainer that actually gets at any of what we couldn't answer this week, post it in the channel, and we'll take another stab at it. So I think we should actually maintain a running list of topics that we failed to study effectively. Hit list. All right. See you guys next week.